Hello, Honors Chemistry students. This is Mr. Spurk, and this is your Chapter 6, Section 1 notes on organizing the elements. So to start, we need to go in a time machine way back to a time and try to think about chemistry before the periodic table. Because the periodic table is arranged in a very specific way, and so we're going to talk about how that came to be. So, by 1700, only 13 elements had been identified. But chemists suspected that there were many more, and experimentation led to many more discoveries over time. So one of the first chemists who was studying this was Antoine Lavoisier. He was a French chemist who compiled a list of the known elements during his time, and by this time there were 33. And he organized them into 4 categories, and those 4 categories were gases, metals, nonmetals, and earths. After his time in the early 1800s, I'm sure you've learned about the Industrial Revolution. The Industrial Revolution led to the discovery of many more elements because we were developing new methods, new materials, and new tools to experiment with. So early chemists used the properties of elements to sort them. So you see here, there are 8 groups, and within those groups, there are elements. So the groups, just like on the periodic table now, are in a vertical column. And if you look at this, you might notice that some of these are in the order that we still have them in today. For example, hydrogen, lithium, sodium, potassium, and rubidium down group 1. Those elements are still in that order today. Another chemist, his name was John Newlands, and by his time there were 70 elements, and he organized them by atomic mass. And so that, again, is how the periodic table is arranged today. And what he discovered was that the properties of the elements repeated every 8th element. So he was listing them in order from atomic mass, from lowest to highest mass. And what he noticed was that every 8th element, their properties seemed to repeat. So periodic is a word that means a repeating specific pattern. If you've ever heard a newspaper called a periodical, that's because they were published periodically. And he named this pattern the law of octaves. The next guy we're going to talk about is J.W. Dobereiner, and he published a classification system. He put elements into groups of 3 called triads, and a triad is a set of 3 elements with similar properties. So he found elements that were similar in properties, and what he noticed was that there were typically 3 elements that were very similar. Then we get to the father of the periodic table, Dmitri Mendeleev. Dmitri Mendeleev published the very first periodic table, and he also followed repeating patterns and properties. He arranged the elements by atomic mass, and he grouped them, again the groups are columns, by similar physical and chemical properties. So Dmitri Mendeleev, his first periodic table you can see over here on the right. It is much different than the periodic table that we see today, but if you notice, you should see that here is group 1, group 2, group 3, and as you go across or down the rows, you notice that their atomic mass or their atomic number increases as we go through. Now, something important to note is that he has some of these with question marks. So this is where he was predicting elements, where he thought elements would be or that would exist, but they didn't yet. Even here, he had gold, and he had estimates of what their masses were. But there were 2 problems with his periodic table. The first one was that some elements were out of atomic mass order because of their properties. So they didn't quite follow that in order of atomic mass rule because he grouped them also based on their properties. And the second problem was that there were gaps. And you can see there are many holes in the periodic table here. But he assumed that these gaps are where undiscovered elements would be found. So the repeated patterns were so specific that Mendeleev was able to accurately predict the properties of undiscovered elements. So like we said here, because of this pattern, and there was holes there, he could assume that there were elements there, and he was also able to predict what their properties would be before these elements were ever discovered, all because of how they were arranged. Henry Moseley was a guy that we talked about when we talked about the discovery of the atom, so he comes back into play here. So Mendeleev's periodic table was based on increasing atomic number, and the atomic number was discovered by Henry Moseley. Remember that he said that the atomic number is equal to the number of protons. But Henry Moseley proposed the periodic law, and the periodic law says that there is a periodic repetition of chemicals and physical properties of the elements when arranged by increasing atomic number. So, looking at the periodic table, we have what we call periods, which are the horizontal rows. There are 7 periods, which correspond to the 7 energy levels that we've discussed. There are more elements in the higher numbered periods because there are more orbitals in higher energy levels. And we know this to be true when we look at the periodic table and when we've done our electron configurations. The properties of the elements across a period change from left to right. So we'll dive more into that. So elements that are on the left of a period are much different than elements that are on the far right. The groups are the vertical columns, and due to they are arranged by their increasing atomic number, there is a periodic repetition of their physical and chemical properties. Elements that have similar chemical and physical properties end up in the same group in the periodic table. So now we're going to talk about some classifications. So the periodic table is typically color-coded, and we did this when we created our class periodic table. Elements that are written in black print are solids at room temperature. Elements that are written in blue are liquids. Elements that are written in red are gases, and these are all at room temperature. And there are 3 categories of elements. There are metals, which make up 80% of the elements. There are nonmetals, and there are metalloids. So if we look at the periodic table here, we can look at them color-coded. So you see that the metals are written in, or they are color-coded in yellow. And we can break them up into their blocks. Remember, we have the S block, the D block, the P block, and the F block. So as you can see, most of the periodic table is metals. And a large portion of it, the D block, is what we call the transition metals. And we'll talk more about those later this chapter. We have our metalloids, which are in between our nonmetals and the metals. And then we have our metals over here on the right, as well as hydrogen. So, properties of metals. Metals are malleable, which means they can be hammered or rolled into sheets. They are ductile, which means they can be drawn into a wire. They are excellent conductors of heat and electricity. They have luster, which means they are very shiny. And they are solid at room temperature, or STP, which stands for standard temperature and pressure. The only metal that is not a solid at room temperature is mercury. And metals lose electrons to form cations, which we'll talk about later this chapter. And metals have a sea of mobile electrons, which result in electrical conductivity. So, metallic character is how metallic an element is. So francium in the bottom left corner of the periodic table is the most metallic element. So elements that are near francium are very metallic, and elements on the other end of the periodic table are far less metallic. So these are the least metallic elements. So now let's talk about the metalloids. The metalloids are this green group here. The metalloids are semiconductors, which means they are good or moderate conductors. They are typically used in computer chips. They also have luster, which means they are shiny. They are brittle, which means that they can be shattered very easily. And they are, like I said, used mostly in computer chips. Silicon is very popular. Properties of nonmetals, so this is that blue group over here, as well as hydrogen on the other side of the periodic table. They are very poor conductors of heat and electricity. They are very brittle, so they will shatter when they are struck. And they're very dull if they're solids. And they gain electrons to form anions. So here's sort of a summary of all the different properties that we've talked about. So you can write some of these things down, add them to that chart in your notes, and you'll be on your way. As always, all the slides have been acquired and adapted from PearsonChemistry.com, the 2012 edition of the textbook, the resources CD, and PearsonChem.com. Have a great day.